Hey everybody, we're talking about trigonometry today, and hopefully this looks familiar. We're talking about right triangles. We know that a right triangle is a triangle with one right angle. And if you remember from geometry, the side opposite the right angle, or the longest side of the triangle, is called the hypotenuse side. And the other two sides are typically called the legs, right? And remember, one of the most famous theorems that you learned, probably it seared into your brain, is the Pythagorean theorem, where we know those two legs squared and added up equals the third side. And we know the hypotenuse is usually called side C, and that either leg could be called A or B. So another thing that you probably learned last year was this idea of trigonometric functions. You probably learned sine, cosine, and tangent. So remember, sine is the function, it's abbreviated sin, or we say sine. Cosine is abbreviated cos. Tangent is abbreviated tan. Cosecant is abbreviated CSC. Secant is abbreviated SEC. And cotangent is abbreviated cot. Okay, so a couple of things that you need to know about trigonometric functions. They are a ratio within only a right triangle. So let's say this was the angle we're talking about. This right here is called theta, which is the Greek letter, and we use it a lot in math to describe an unknown or a reference angle. Okay, so here's our angle theta. We know that we would always call the longest side of a right triangle, we always call this the hypotenuse, or the hype, right? The abbreviation for that would be the HYP for hypotenuse. And then these two legs, we do have specific names for them. The first one is wherever our angle is, so this is our angle, the side opposite that angle is the opposite side, or abbreviated OP, OPP. And then the side left over is the side that touches the angle and the right triangle, or excuse me, the right angle here. And this is called the adjacent side, or ADJ for adjacent. So to find these ratios, sine, cosine, tangent, cosecant, secant, and cotangent, these are ratios within the right triangle. So we'd say the sine, or the ratio of sine of this angle theta, and hopefully remembered from last year, we have this saying, sometimes you hear about a story about a Native American woman, or sometimes you hear a joke about what to do if you stub your toe. You soak TOA. Okay, so remember, S stands for sine, and OH stands for the opposite and the hypotenuse. So sine is the opposite side divided by the hypotenuse side. Okay, cosine is the adjacent side over the hypotenuse side. So cosine of the angle equals the adjacent side over the hypotenuse side. And then tangent is the opposite over the adjacent side. So here we go. We say this is the opposite over adjacent side. So you're probably thinking, yeah, Mrs. Salles, I already know SOHCAHTOA, but what in the world do I do with secant, cosecant, cotangent, all that stuff? Well, here's what we know about cosecant. Cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, then the cosecant of theta is the reciprocal of opposite over hypotenuse, which is flipped. So we'd say that's the hypotenuse over the opposite side. Go ahead and write that down. Secant is the reciprocal of cosine. And so if cosine is adjacent over hypotenuse, then the secant of theta is the reciprocal of adjacent over hypotenuse, which is going to be hypotenuse divided by the adjacent side. Go ahead and write that down. And then lastly, cotangent, you might have guessed it, is the reciprocal of tangent. So the cotangent of theta is the reciprocal of tangent. So if tangent is opposite over adjacent, cotangent would be adjacent divided by the opposite side. Okay, so now we're going to use that information, keep it right in front of you. We're going to use that information to do our first example. So it says evaluate the 6 trig functions of angle theta for this triangle. So here's what we have. We've got one side, we've got a second side, and we do not have this long side, which we know is the hypotenuse. So first things, we need to know what that hypotenuse is because we're going to need all 3 sides. So remember that a squared plus b squared equals c squared. So we can write 5 squared plus 12 squared equals c squared. So we get 25 plus 144 equals c squared. Is 169. Take the square root of both sides because we want to get c by itself, and we get c equals 13. So beautiful. Now we've got all 3 sides. So step 1 to find the 6 trig functions is, first we're going to label the triangle with the hypotenuse, the opposite, and adjacent sides. So remember, we always mark the angle first. So here's our angle for theta. That is going to tell us where the opposite side and the adjacent side are. So hypotenuse, we've already labeled, that's right here. Remember that the opposite side is always opposite the angle theta. So here's angle theta, and the side opposite here is 12. So the opposite side, we just labeled it, which means the side left over is the adjacent side, also because it's touching the theta and the right angle. Okay, so now that we've got this labeled, step 2 is we're going to set up the 6 trig functions. Okay, so we have sine, cosine, tangent, and then remember sine and cosecant are reciprocals of each other. Cosine is a reciprocal of secant, and then cotangent is a reciprocal of tangent. So we're going to set those up. Okay, so now we're going to find them. And then we're going to use so, ca, toa to solve the rest. So remember, sine is the opposite over hypotenuse, which if this is the opposite side, that's 12, and the hypotenuse side is 13. Now, what's nice about this is I'm just going to stay right here on this line, and now I'm going to do the cosecant. Remember how I said the cosecant is the reciprocal of sine? So I'm going to go right here and do the reciprocal of 12 over 13, which is 13 over 12, and that's my cosecant. All right, let's do cosine now. So remember, cosine is right here. C is A over H, so that's adjacent over hypotenuse. So let's do this in a different color. So we've got our adjacent side over the hypotenuse side, which is 5 over 13. And remember, secant is the reciprocal of cosine. So I'm going to look right here now, and I'm going to take the reciprocal of 5 over 13, which is 13 over 5. And lastly, we have tangent, which is the, right here, I'm going to put it in blue, O over A. So opposite over adjacent. So remember, the opposite side is right here, and the adjacent side is right here. So it's 12 over 5. And the cotangent is a reciprocal of the tangent. So we're going to take the reciprocal of 12 over 5, and it's 5 over 12. So it sounds like it was going to be crazy, but it's really, really not. Okay? So now let's talk about some special values for special angles. So hopefully you remember seeing these special triangles that have special values in geometry. So we know there's a 30, 60, 90 triangle with sides of 1, the hypotenuse is 2, and the other side is the root of 3. And then we have a 45, 45, 90 triangle with sides 1, 1, and the root of 2. So those special triangles, there's a really easy way to remember that, and I made this little saying up, okay? So if we're looking at those common values of 30 degrees, 45 degrees, and 60 degrees, there's a saying. You always set this up just like this. This is a a table. So we do the degrees on the top, and sine goes here, and then cosine. So we go 30, 45, 60, sine over cosine. And it's, say it yourself, you say it's as easy as 1, 2, 3. And here's what that means. 1, 2, 3, and then 3, 2, 1. Okay, it's as easy as 1, 2, 3, 3, 2, 1, all over 2. So we're going to put everything over 2 now, all over 2. And then we say root, 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 root. And here's what I mean by that. The numerators have roots on them. So the root of 1 is just 1, so we leave it alone. So we go root 2, root 3, root 3, root 2. So that's root, 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 root. And those are all your values for those special trig functions. Now, to find tangent, remember, if you remember it correctly, sine over cosine is equal to tangent. So if I take 1/2 divided by the root of 3 over 2, I actually end up with the root of 3 divided by 3. The root of 2 for sine over the root of 2 for cosine is 1, because anything divided by itself is just 1. And then the root of 3 over 2 divided by 1/2 is just the root of 3. So if you wanted to remember that, great. But the most important one that you remember is the sine and the cosine, because if you remember those two values, everything else comes from that, those values, okay? So here's our third one, okay? So here's what we need to know. So it says find the value of x. So here's what we need to know. We've got this side here, so we know this side, we'll call this the opposite side. Here's our hypotenuse side, right? And here's our adjacent side. So we're given the hypotenuse side, and we're looking for the adjacent side. So if I use SOHCAHTOA to help me know which trig function we use for what. So remember, we've got the hypotenuse side given to us, and we're looking for the adjacent side. So which one of these trig functions deals with the hypotenuse and the adjacent? I see a hypotenuse here and an adjacent here, so we are going to choose cosine. So for step 1, we're going to choose the trig function to use. Once we're done choosing it, we're going to set up the equation using the trig function, okay? So if we're going to use cosine, we say, okay, the cosine of the angle, which was 30, equals the adjacent, which is x, over hypotenuse is 8. And then step 3, we're going to just solve. So if I'm solving for x, I need to get x by itself. So I'm going to multiply both sides by 8. So I get 8 cosine of 30 equals x. Okay, well, remember, I know what the cosine of 30 is. It's in my chart. The cosine of 30 is the root 3 over 2. So we can say 8 times the root of 3 over 2 equals x. So that gives me 8 divided by 2 is 4, root 3 equals x. And that is my answer. All right, last one we're going to do is, now this one's a little bit more intense because we're solving. This solving means find every angle and side. So we need to find angle A, angle B, angle C, and side A, side B, side C. So here's what we've got. Right now, I've got angle C is 90 degrees. We see that right here, right? And I see that angle A is 28 degrees. We could really quickly find angle B because we know all triangles have angles that add up to 180. So I know angle A plus angle B plus angle C equals 180 degrees. So that's 28 degrees plus, I don't know, we're just going to leave it as angle B, plus 90 degrees equals 180. So 28 and 90 is going to give me 118 degrees. So if I take that away from 180, we get angle B equals, I'm going to do that on my calculator, 180 minus 118 is 62 degrees. So we've got angle B is 62 right here. I'm going to write it in there. And now we're going to find all of our other sides. So here's what we've got. We already have side B. So we just need side A and side C. So let's do what we did before in that last example. I'm just going to mark 28. I'm just going to make that the angle I'm going to use. So if I'm looking for side A and I'm given side B, remember I'm going to label this opposite. This is the hypotenuse side, and here's my adjacent side. So I'm looking for the opposite side, and I'm given the adjacent side. So remember, using SOHCAHTOA, I'm going to decide which trig function I'm going to use. So I'm going to write it out. Always make it visual. CAHTOA. So I'm looking for the opposite, and I've got the adjacent. Opposite and adjacent, I see it right here. Opposite, adjacent. So that means I'm going to be using tangent. So let's set up that equation. Tangent of the angle, which is 28, equals the opposite side, which is A, over the adjacent side, which is 15. Let's solve for A. Multiply both sides by 15. You can use your calculator for this. In your calculator, you're going to go 15 times the tangent of 28. Make sure that your mode is in degrees. If you're not sure how to do that, ask me. So if you go 15 times the tangent of 28, we get A is 7.975. We're going to call that 8.0. We're going to round it to the nearest tenth. Okay. So now here's your choice. You can still use SOHCAHTOA, or because we have two of the three sides, we can use the Pythagorean theorem now. So if I know A squared plus B squared equals C squared, I can say 8 squared plus 15 squared equals C squared. 8 squared plus 15 squared gives me 289. Take the square root of both sides, and we get 17 equals C. And we're done. Okay, I'll see you in